Hi, welcome to Unit 8. In this unit, we're going to talk about the lunar cycles, and we're going to talk about eclipses, okay? Solar and lunar eclipses. So here, we identify the phases of the moon. We're going to predict where and when the moon will be in the sky, depending on its phase, and describe how the solar and lunar eclipses happen, basically when the path of the sun and that of the moon and that of the earth basically line up, and then explain why lunar eclipses or solar eclipses do not occur on a monthly basis. Here is a relative position of the sun, the moon, and the earth. The moon revolves around the earth, and the earth actually goes around the sun. Throughout the year, throughout the lunar month, basically, we will see a full lunar cycle. We start with the new moon. For about 7 days, the lunar moon starts to grow from nothing at all to a little bit of a crescent. The crescent is growing. Then a quarter moon sometime around after 1 week. And then that quarter moon starts to grow still further to become a gibbous until it's a full moon. After that, from a full moon, it starts to decrease, but in the opposite direction. Okay, you have to pay attention. Here, the dark side is facing toward the east. The lit side is facing toward the west, where the sun is setting. You're still in that framework. The lit side is facing to where the sun is setting. The dark side is facing toward the opposite direction, toward the east, until it's completely lit. Then after that, the lit part is going to be facing where the sun is rising from, which is the east, and the dark part is facing toward the west. So if I see the lit part facing toward the east, I know immediately I'm in the second half of the lunar cycle. If the lit part is facing toward the west, I know exactly that I am in the first half of the lunar cycle. And this process will continue until I lose half of the lit part. It becomes a quarter moon, or third quarter, that is, because it's not the first one. The second, that 2 quarters you have, and then third quarter, and then it becomes a crescent, decreasing crescent, until it vanishes completely, and the whole thing repeats. Okay, this is how you can think about it. The moon is facing the sun, so the lit part is facing the sun, the non-lit part is facing the earth. The full moon is the opposite. The moon is facing the sun, and we see that. So that's the lit part, the full moon. Quarter moon, the lit part that is facing the moon, we see it, and half of the moon is, the other half is facing away, whether being a third quarter or first quarter, it's the opposite, that's all, okay? So that's the whole thing going around the earth. Okay. If we count this from cycle to cycle, it doesn't matter. From new moon to new moon, from full moon to the next full moon, that is. From this quarter, first quarter, to the next first quarter. Not the third quarter. The lit part needs to be facing in the same direction. It doesn't matter. From whatever phase to whatever phase, on average, we'll find 20.5 days. That is not the actual rotation of the moon around the Earth. The better version of that is to actually track it with respect to the stars. If we go and see it next to this star, we will wait until next time it lines up itself with that same star. That is the actual rotation of the moon, and that is the sidereal month, similar to the sidereal day when we were talking about the rotation of the Earth around its own axis. This is the rotation of the moon around the Earth. Again, let's say we're looking at new moon. Okay, the sun is here, the moon is here, the Earth is here, and the stars are far away. If we wait for it to line up itself exactly in the same orientation as the stars in the background is, it would have made a full cycle around the Earth. But it's still not lined up corresponding to the sun because of the fact that the Earth is not in this place, in the same place. It's moving. So to account for that is the extra 2 days and some change to allow for the moon to line up itself with the Earth and the sun in the same line of sight. That way we have a new moon. So the actual rotation is only 27.3 days because that's how I see it with faraway stars where we are not revolving around. Okay? So that's the actual rotation of the moon around its own, around Earth. So this is really the actual rotation, and that is what we refer to as sidereal month. For Newton, when he came up with his equations for the laws of gravity, he could not use 29 and a half because that's not the actual rotation of the moon around the Earth. He had to use 27.3 days because that's the actual rotation of the moon around the Earth. That is what the sidereal month is, as opposed to the lunar month, which has to do with the cycles. So, in a sidereal month, the moon started from full moon, ended up in a quarter moon, by the way. I'm sorry, in a crescent moon. So you could start from one phase to a different phase altogether. You may end up in the same phase. If you started with a little bit of quarter, you could end up with more quarter. I'm sorry. If you started with a crescent moon, you could end up with more crescent moon. If you started with a gibbous moon, you could end up with a less gibbous moon than before. If you start with a full moon, you may end up in a gibbous phase of some sort. You guys understand? So the phase may not be the same if you refer to the actual rotation of the moon around the Earth, which is a sidereal with respect to the stars. But by definition, the lunar month is the same phase. So if you start from quarter moon, you have to come back to the same phase. If you start with a new moon, you have to come back to the same phase. If you start with a full moon, you have to come back to the full moon. On average, that's 29 and a half days. And that's why, if we remember from Unit 8, the lunar calendar has on average 29 and 30 days. So sometimes it's 29, sometimes 30 days, averaging to 29 and a half days. Exactly how it should be. Okay. I mentioned that briefly of how the moon. So in the beginning of the lunar month, remember when the moon is new moon, the Earth and the moon and the sun are lined up. So when the sun is setting, you can see the moon behind it, between us and them, between us and the sun. The next day, the sun dips and the moon is still up in the sky. So now you see a crescent because of the reflection of the sun of the day after is going to be even higher in the horizon when the sun is setting. Okay? And that gives you a bigger crescent. If you wait about a week, it's going to be a quarter moon. When the sun sets, the moon is still visible well in the sky, quarter moon. Later in the month, it's going to be a crescent. When the sun sets, I'm sorry, not crescent, a gibbous. When it's setting, there is a gibbous, and that gibbous is growing. So we call it a waxing gibbous, as much as we call this crescent a waxing crescent because it's increasing. Okay? By day 15, midway in the lunar cycle, when the sun sets, the moon rises in the east, all of its glory. So basically, the Earth is sitting between it and the sun. Okay? And if we continue with this cycle, the next time, basically, the next morning, day 16 if you wish, well, the moon has crossed all the way all night and traveled in here, the sun starts to rise in the opposite direction. And then the next few days is going to be a waning gibbous because gibbous now is shrinking until it's quarter moon. But look at this difference between this quarter moon and this quarter moon. This quarter moon is facing the sun that is setting in the west, and this quarter moon is facing the sun as it's rising in the east. So this is the third quarter, whereas this one is a first quarter. This is a dawn. This is a sunset. This is a dawn. You have to make that distinction. This is an early in the morning as opposed to this one. This is when the sun is rising. This is when the sun is setting. And that's basically how the lunar cycles are. Okay. Again, you can track it down. We have new moon when there is zero visibility of 0% lit of the moon. 0 day of the moon, 0% lit, waxing crescent increasing in from 0 all the way to 50% lit, from 0 to 7.5 days roughly. From 7.5 days, around 7.5, it's a quarter moon, first quarter that is, because 50% is lit. Okay. Waxing gibbous, it's more than 50% going all the way to 100%. That is 7.4 days, 7.5 days to almost 15 days. That's a waxing gibbous. At around the 15th day is a full moon, 100% lit. If I see it 95, I would say 100%, because I can't tell with my eyes if it's 95 or 97. It's the same thing. Waning gibbous starts to shrink further from the midway of the month all the way to 22 days. And then it's going to be around 22 days, it's going to be a third quarter. Lit part is facing the east now, it's not facing the west. Waning crescent, it's a crescent now that is starting to shrink even further and further to become smaller and smaller as a crescent. And that's going from 50% down to 0%, and a new moon again around 20.5 days. Okay. Why we don't have lunar eclipse? I mean, we will have a lunar eclipse or a solar eclipse depending on the position of the sun and the earth and the moon with respect to one another. If the moon sits between the earth and the sun, then in this case it's blocking the view of the sun. Remember, there is an exercise for you guys where you kind of compute the ratio of the radius of the sun to the radius of the moon versus the distance to the sun to the distance to the moon, and you'll find that it's a perfect the same ratio almost. So that's why during a solar eclipse they cover one another. The moon covers the sun. A lunar eclipse, the other way around. The earth covers the moon. Okay? The moon passes in the shadow of the earth. Okay? You have to understand that when you're looking at the solar eclipse, it's not happening everywhere in the same thing. So there is a path of totality where the moon starts to move. As it moves, it blocks that region, and that falls in the umbra. Partial eclipse will happen in the region where there is a little bit of shadow, if you wish, and that is penumbra. So that's really the distinction between partial eclipse and a total solar eclipse. There is a kind of exercise and a problem that hopefully you guys will take care of it, and that has to do with the Mayan calendar and how they track the solar eclipse. It talks specifically about the August 2nd solar eclipse that's going to happen somewhere in southern Europe and North Africa. And based on that, you're going to make a calculation to predict when the next one will happen here in North America. Okay. But this is the path of totality that you can see in here. This is where the total solar eclipse. The other regions of the Earth will not even know that there was an earthquake. There was a solar eclipse altogether. But if you are nearby, you may be seeing a partial solar eclipse. Okay. Lunar eclipse, on the other hand, as I said before, it's actually the Earth that covers the moon. So in this case, the moon starts to change color and goes all the way to red, and has to do with the fact that there is still atmosphere on the Earth that's going to deflect the radiation of the sun that goes and shows us part of the. So the color in here is coming from the particles in the atmosphere on Earth. Okay, and so that's a lunar eclipse. And again, this is how the shadows work and the extent of the lunar eclipse. So why there are no, because there is a new moon every month, lunar month, 12 times a year. There is a new moon is where the moon sits between the earth and the sun. So why we don't have solar eclipse 12 times a year? Why don't we have a lunar eclipse 12 times a year? Because again, the earth will cover the moon technically 12 times a year during the full moon. So we have 12 full moons a year. We have 12 new moons a year. So technically, we should have a spectacle, but we don't have that. It's rare. The reason being is because the Earth, as it goes around the sun, it goes in the ecliptic plane. And the moon, as it orbits the Earth, it orbits it on its own plane. And these two planes are not exactly superimposed to one another. They are not parallel to one another. They are not on the same level to one another. There is an angle between them, and that angle is 5 degrees. And that angle does not stay the same. So sometimes it's far away. So when there is a lunar solar eclipse, because the moon is making a shadow, but it's not making it, the Earth is making a shadow, but it's not making it on the moon, and vice versa. The moon is blocking something, but not in our line of sight. In other words, when we're looking here, we're still seeing the sun. Okay? During a new moon. When we are here looking this way, the shadow of the Earth extends forever, but the moon is far away. So there is no need to have solar eclipses and lunar eclipses 6 times, 12 times of each, okay? Once every month. It's only when there's two orbits, when there's two planes. So this plane of the moon is not staying in its place. It's going up and down. So when it lines up, that's when we will have a solar eclipse and a lunar eclipse in the same time, in the same month, okay? Somewhere on the Earth. And because, as I said before, the shadow is not that big to really, but the solar eclipse also the same thing. You have to be in this right location to see the moon blocking your view of the sun. So it's not also happening everywhere in the same time. So again, this plane is moving, and it's only when the ideal conditions are where this points, where these two planes meet, when we have solar eclipses or lunar eclipses for that matter. And the average is about twice a year, somewhere on Earth, not necessarily where we are. Thank you.